building an end-to-end application, like how you can build an application using the AI, which is Gemini, we will be taking care of, and then learn about RAG and also how you can deploy it as an end project as well. And soon, I expect some of you might be going to build a product on it as well. Whenever you want to talk about anything or feel like you have any questions, feel free to shoot them in the Q&A section or in the message section. We are here to take care of them. And we do have polls as well. So from time to time, you're gonna get some polls on your screen as well. So do interact with them and let us know how you feel or whatever you have the knowledge about it, so that we can also deliver better things in future. Now, starting ahead, we have Sumit Kumar here. Sumit is a solution architect at 66 Degrees and is also a Google developer expert in Google Cloud. And it's amazing to have him here on stage today, and love the information that he has shared with us in person from time to time whenever we have interacted. So we have invited him in this community event today and hope all of you enjoy and learn from this session today. Over to you, Sumit.
Thank you, Abhishek. So let me share my screen first. And let me know if my screen is visible. Is it visible?
Yes, it's visible.
All right. So I hope everyone can see my slides. So, all right. So very good morning, everyone. Thanks for joining today's session. My name is Sumit Kumar, and I work at 56 Degrees as a cloud solution architect. And I have been working in the tech industries for over 15 years now. And I'm a Google developer expert in GCP and AWS community builder. Some of you might already know me through community event or maybe during tech talks. But if you haven't connected yet, feel free to reach out to me on LinkedIn or other social media platform. You can just scan this QR code shared in this session. If you are interested in learning cloud, DevOps, or AI, you will definitely find a lot of helpful blogs and articles and videos that I have shared on my social media platform. It's a great resource to kickstart your first journey. So before we begin, I kindly request everyone to stay on the mute during the session to avoid any distractions. And then we will have around 10 minutes for Q&A at the end, if time allows. So feel free to note down your questions as we go. So today I will be talking about how to build an end-to-end AI application on Google Cloud using RAG. RAG stands for Retrieval-Augmented Generation. It is one of the most critical component of today's AI application when it comes to the enterprise grade architecture. So we'll talk about that later. So the first thing, we will start with the basics of generative AI. What is how this model works and why it matters. And then I will dive into the RAG, how it helps answer questions using your own enterprise data. And then finally, I'll walk you through a live demo where you will build an AI app that use a private enterprise data. Sorry, just a second. Yeah, so I'll walk you through the live demo where we will build an application, an AI-based application that use enterprise data or your private data via the data stores with built-in RAG capability. And we will also test it by asking the question and checking if the response are accurate and useful. So I'm looking forward to an insightful session with you all. So let's start with why AI is gaining so much popularity. So, did you know AI as a term is almost 70 years old? It is not a new thing. It was first coined in 1956. So, why is it only now that we see AI everywhere, right? Why AI is gaining so much popularity in the recent years? You can see AI in your phones, in our cars, in our homes, right? The reason is very simple. Back then, we had a very tiny or a very small amount of data, and very slow computers, and hardly any storage, right? So teaching a computer to think was like trying to teach a goldfish to drive. So which is not going to happen. But today we have a oceans of data flowing in every seconds. We have a fast GPUs and cloud computing. We have a algorithm which are smarter than ever before, and we have a storage that can hold massive amount of information. Now AI has everything it needs to shine. You see AI in your daily life. You say, let's say you say to Siri, like, hey Siri or Alexa, play any song, and it responds, right? This is a part of the AI, but it is not a generative AI. We'll come to generative AI. Second example is you browse a t-shirts on Amazon, and the next day it started flowing on your Instagram, YouTube, or even on the Facebook. The fun fact is 45% of the Amazon revenue comes from its recommendation engine, and 75% of the Netflix users choose what to watch because of the AI recommendation. These all these examples are the part of the AI recommendations. So it was way before the generative AI. Now you must be seeing self-driving cars, chess playing boats, right? Language translator. These all are powered by the AIs. Now let's understand what is generative AI. So we'll talk about what is generative AI, what kind of data is generated by the generative AI, and how generative AI works. So generative AI is a type of artificial intelligence that can create a new content. So generative AI can generate a new content which can be image, text, audios, and videos. And these generation model learns from data it's trained on to create the entirely new content by understanding the pattern and structure. Chat GPT, Gemini, Cloud AI, all these are very popular example of the generative AI. I believe everyone is using generative AI on your phone, on your day-to-day activities. So these are nothing. These are a kind of a generative AI fueled by the models, the generative AI models. You you just start sending the prompts, and it generate the response based on your prompt. Right? There are many now these days. These generative AI models are integrating into almost any application. We'll talk about this later. Now, before ChatGPT or Gemini become very popular, there are some models like DALL-E, Stable Fusion, Midjourney. They were leading the field of generative AI by creating the images. All of these models are example of text to image generation model. So they are way before. Now, DALL-E was introduced in Jan 2021. I think the updated version is DALL-E 2. And then we have a stable diffusion model, which was introduced in August 2022. Sorry. And so now, what are the text to image generation model? So these models takes the input from the text prompt and generate an image that matches the description. So for example, if you write a prompt, a cat wearing a hat and sunglass standing on a chair, the model will generate and the image that visually represent that scene. You can see that on your screen that when I send the prompt, it's generating the image, whatever you are asking AI, generative AI to do. So these were the image generation model. Now let's take a look at how generative AI works. The first step is training the model. To train the generative AI model, we need a large amount of data that matches the type of content the model is expected to generate. So for example, a text generation model is trained on a very vast collections of books, articles, and websites. Similarly, an image generation model is trained on a large data set of images, So during the training process, the model learns to recognize the pattern and relationship within the data, such as sentence structure, image features, or content flow. Now, once the model has been trained, it can be used to generate the new content. It takes as an input called prompt and use what it has learned to produce a new original output that's similar in the style or format its training data. Now, after training, the model is usually deployed if needed, and it can also be fine-tuned using this specific or updated data to improve the performance for a particular use case of the domain. So you might have seen GPT-5 is recently launched just 2 or 3 days 3 days back. What exactly is that? This is a generative AI model which is trained on the latest data with latest capabilities, right? And these are not deployed on the local machine. These are deployed on a data center, on a cloud, right? Because they need a lot amount of compute power storage, and you can later fine tune it. But what is happening these days, most of the companies like Google, Microsoft, and AWS, they are creating a different model. They are trying to train the model on a new set of use data set, trying to change the capability so that it can perform better and then release it, right? Now let's talk about the resources needed to train large scale generative AI model, as I talked about, like ChatGPT or maybe Gemini or Cloudy AI. These are the large scale generative AI models. So there are four main pillars required to train those large scale models. The first is compute power, memory, storage, and time. The first thing is compute power. So training these models requires a cluster of high performance GPUs or TPUs to handle the massive calculation involved in the processing and optimizing the billions of parameters. So for example, GPT-3 was trained on thousands of GPU over several weeks. It could be several months or even years. Second, memory. Now, these models needs large memory to store their weights and process the huge data set efficiently. Third is storage. This is very important. We need we need massive storage capacity to hold the training data, often in the terabytes, or maybe in the petabytes or more. And finally, the time. So depending on the model architecture, the size of the data set, and the available compute, trainings can take weeks, months, or even in years. So time is very important. Now the question is, can we train LLM on local machine? Yes, it is generally impractical to train large language model like ChatGPT or Llama 3 or maybe any other model on a standard local machine, due to their extremely high computing and memory requirements. But training such model typically requires cloud-based platform that offers access to scalable TPUs or GPU resource. While we can't realistically train these models from scratch on the local machine, we can fine tune them to meet the specific requirement and use case. So for example, we have a open source model like Llama 3 that provides pre-trained model that can be fine tuned for a particular task or application without starting the training process from the zero. So by leveraging these pre-trained models, developer can save significant cost related to the data collections, data processing, and compute resource that is needed for the initial training. So you can use it for the POC or for your some internal experimental purpose, but in production that is not going to be possible. And is not and it is not always recommended. So this is just an optional slide because I am trying to tell you, because there are some way that you can definitely run LLMs on your local machine, because running large language model on local machine can be incredibly useful whether you are experimenting with LLM or developing more advanced application. However, setting up these necessary environments and getting LLMs to work locally can be a bit challenging. So how you can run this local, how you can run this LLM locally without the usual complication. So that's where the Olama comes into the picture. There are other framework also, but you can use Olama, which is a platform that simplifies a local development with the open source LLMs. So Olama package everything you need to run an LLM, including model weights and configurations, into a single model file. We are not going to run Olama locally. Rather, I'll show you the demo on the cloud, because cloud provides managed service and easy to set up. And we will use Google Cloud to demonstrate you the LLM models which are defined. And whenever you create or build your AI-based application, you can directly use those or consume those LLM from the cloud, right? So, but you can, if you want, you can try this. This is the command that you can try it. Okay. Now let's understand what is RAG, Retrieval Augmented Generation. So there are some limitation of large language model or LLMs. The first is LLM can't answer questions about your private data because that data is not a part of their training set, right? Second, they can't always provide the most current information since their knowledge is limited to when they was last trained, right? So this is where RAG, retrieval augmented generation, comes into the picture. This is very important, guys. So RAG allows LLM to use external data source or external feed for the better response. This means that you can give more accurate answers using your private or enterprise data. You can stay up to date with the latest information and reduce the cost of training by avoiding the full retraining of the model, right? RAG works in two phases process. First is it retrieves the relevant information, and then it generates the final answer based on that information. The result is more trust, more control, and grounded response that are backed by the real and verifiable data. RAG is also known as the grounding of your generative AI model. This is the most common technique that you used when you try to grounding on your generative AI application, right? Because your LLM doesn't know everything. It knows only the amount of information that you have given it. So RAG allows LLM to use external data source or external feed for the better response.
Hi everyone. So we are facing a technical issue. Just give us a couple of minutes and we'll resume the session. Okay. Okay. So by the time Mr. Sumit is joining us, we have the chat session also open. So anyone who would like to tell if they are building any cool projects on RAG or GCP or something related to AI that we can know about, or if you have any questions, we can take that as well. And as I see the chat, Aman is eagerly waiting for the event. Thank you, Aman. Hope you have joined it. Govind, do we get a certificate for attending the event? For this one, like in-person events, we try to give the certificates. Okay. All right. So let's quickly have a fun poll as well. Yeah, we have one question here. Let me just.
Yeah, hi. Am I audible, guys?
Yeah, you're audible, Samitji. Uh, we have one question as well, meanwhile, and I think we can take this question post your session. I think
Yeah, we
maybe
can take it at the end. Sure. Yeah,
in between the session as well, the question might be answered. I feel like.
sure.
Okay, over to you, Samitji. Thank you, everyone, for the patience.
Sure. Thank you for your patience. Let me share my screen again from where I left, and just let me know if you can see it. Abhishek, you can see it, right?
Right, it's visible.
Okay, my screen is visible, right?
Right.
Okay. All right. So I was talking about the RAG. RAG works in two phases process. First, it retrieves the relevant information. It generates the final answer based on that example. And so I was talking about RAG. And the next slide is about when user submits a query to the LLM, how and the RAG works with these tools. So imagine you're asking a really smart assistant a questions like, what is the latest research on a climate change? Now, even if the assistant is trained on a lot on a very large amount of data, it might not know the very latest information unless it can go and fetch it from somewhere else. This is where the RAG comes in. So let me break it down in three parts. The first is retrieval. First, your query is taken and transferred into something the system can search with. Often this is done by embeddings. I'll talk about embeddings later, but think of embedding as a way to represent meaning in numbers, right? We use retrieval tools here. The first is vector database like Pinecone. We have a Google managed vector database like Datastore, and we have search engines like Google Search, Bing, and custom search models are available in the Google Cloud. And we have a knowledge graphs. So basically, the system is like Okay, before I answer, let me quickly look up the most relevant information from my source.
Uh, Sorry to interrupt, Sumit. Your screen is not visible. Uh,
Oh, really? I
yeah.
shared it.
Uh,
1 second. Now, can you see
uh,
this?
yeah, it's visible. Thank you.
Okay, let me just rewrite again here. All right. I believe now everyone can see my screen again. So this is the slide I was talking about. So imagine you are asking a question or sending a prompt to your AI. So what is the latest research on the climate change? Now, even if the AI is trained on a lot of data, it might not know the very latest information unless it is trained or it can get it somewhere else. And this is where the RAG comes in. So let me break it down. So retrieval is something that you first you send the query is taken and transferred into something the system can search, right? And often this is done using the embeddings. Think of the embedding as a way of representing the numbers or vectors, right? And you can store those embeddings like vector database, data store, and you can use the search engine to find those embeddings. So basically, the system is like, okay, before I answer, let me quickly look up the most relevant information from my source. Now, second is augmentations. Now that the relevant document or the piece of informations are retrieved, they are added into the original questions prompt, and this is called augmenting the prompt. So now the LLM is not answering blindly; it has extra context, like giving an open book exam instead of a closed book one. So you can think about augmentation like that. Now generation is now comes the LLM turns. It processes the augmented prompt, the user questions plus the context. It generates a final answer because the prompt includes the relevant, up to date, and specific information. So what will happen? The answer will be more accurate and it has more trustworthy source of information. So in very simple terms, retrieval gets the facts, augmentation feeds those facts into the prompt, and generation produce the final answer. Very simple, in a very simple terms. This is the example of the RAG. Now, this is the diagram of RAG flows, how it works using a very simple example. There are many examples, but let me just explain you with a couple of architecture. So imagine a customer asks a chatbot, what is the status of my order, right? Generally what happens if you ask question to, let's say, Zomato or any e-commerce website, these the information of your order is stored in their private database, right? They are not open to the LLM. So here let's first understand, if someone asks what is the status of my order, the step one is retriever. The retriever goes and search the right place, maybe your database. In this case, it is your database. It could be PDF, it could be web page, depending on how you are storing those database. And then it pulls the exact detail about the order. Now, second step is augmentation. Now, system combines the customer original questions with the retrieved information, and this becomes your augmented query. So basically, the question plus the answer data together. Now, step three is generation. Now, finally, the LLM, large language model, use that augmented query to generate a natural human-like response, such as, the answer could be your order was dispatched on this date, right? So this is how the RAG model flow looks like. So instead of the AI guessing, it's getting the fact first, then answering, which means more accurate result. This is another diagram wherein I have specifically, in this design, let's say we want to build a chatbot that can answer your using the private data or your own data. So we are using the RAG approach to feed the external knowledge. In this case, your private data set into the LLM. So the LLM we are using here is Gemini 1.5 Pro. So the flow is document is gets converted to the vectors by embedding model, and then those embeddings get stored into the vector database by using some embedding models, and then user query gets converted to the same vector format, and then it find the most relevant document, and finally it generate the answer using the retrieved context. Just a second. Okay, now let's talk about what is vector and embedding. This is most important component of the RAG, because without it, RAG is not going to work. This is the foundational of the AI, I would say. So think of vector as a list of numbers that computers use to represent the informations, like turning text or any images into the format machine can understand. Like our computer understands 0 and 1, right? Whenever you type something, it understands 0 and 1 language, binary language. Similarly, AI understand embedding language, right? Because you have to, if you are using the Google search, what is Google search? It actually is semantic search, right? All your data are basically stored as a vector in a numerical representations. So embeddings are special vectors that captures the meaning and context of text, not just the words. So they are created by the embedding models, which is trained to understand how words and phrases related in the meaning. I'll explain you in the next slide. So think about vector or embeddings are a numerical representations of your data, right? You give some numbers to certain words. So this helps AI compare and find similar ideas, even if the exact words are different. It's a very similar way. Like if you go to the Amazon, you find some products, it'll give you some similar product, right? How it happens behind the scene because of the vectors and embeddings. So, for example, cars and automobile will have the embedding that are very close to each other, because car and automobiles are something that are having some relationship, right? Like close relationship. So this is how the vectors and embeddings are. Now, talking about embedding more, like embedding is a vector list of floating point numbers. So embedding is a data-like word that have been converted into the array of numbers that known as vector that contain the relationship, right? So let me describe here in a very simple word. If you see this in this picture, there are some words like wolf, dog, puppy, um, cat are often used in a very similar situations, and in the vector terms, that will represent as a numerical values closest to each other. While this is a very basic example, but in reality there are hundreds of dimensions. There is also an image, right? Images can also be turned into a vector too, and this is how Google search do a similar image searches. If you are using the Google search, this is exactly you see the results, right? The image sections are broken down into the array of numbers, allowing you the pattern of similarity. So here you can see that in the image you have a leaf, you have a color, you have certain attributes of this image. So these certain attributes are placed together depending on their relevance in some dimensions in a vector format, or using some embedding model where they store this called a vector database. So once the embedding is created, it can stored in a database. Right now, there are many databases available to store those embeddings. You can store it into a MySQL database, NoSQL database, but there are some special database available for the AI purpose to have some better performance when users are doing the semantic search. So these database is called a vector database and can be used in a several ways, including searching, including clustering, recommendation. Searching is the most commonly used, and you have been using it since decade, right? Now let me explain you the actual architecture of the RAG, how it works behind the scene. This is the core architecture of RAG. So Just carefully look at this architecture. There are two phases: pre-production and in production. So in phase one, like pre-production, before you ask a question, it takes the document, right? It takes the document. It could be any private document, and then it cut into a smaller piece. We called it chunking. Who does this? Embedding model does this, right? We have a OpenAI model. We have a model from Google. These models help those. Now, what happened? These models convert text to the numbers or embeddings. When we say convert text to the number, we can simply think about embedding, and then store in a database. Now you have a searchable knowledge database, right? You have the document, you converted it, and then you put it in your knowledge based database. Now coming to phase two in production, when you ask a question, system search for the relevant piece, right? As I talked about, and then it find the best matching content, which then it gives it to the AI. Then AI read the content plus the questions and then give you the smart answer, right? Simple analogy, it's like having a super fast librarian, right? If you are going to library, what happens? First, in library, you organize all the books with a special tags, right? And then later, when you ask something, librarian instantly find the right books and give you the answer, because they know, because they have tagged it with certain numbers, right? Therefore, they can easily find the books, whatever books you ask for. This is exactly works in the rack system. Okay, so RAG implementation on GCP using Vertex AI and Gemini model. This is the a very simple architecture, like wherein we have a data store, we have a Vertex AI assistant, and you also seeing Terraform. If you are familiar with Terraform, you know that Terraform is used to deploy the infrastructure. Is the infrastructure as a code. So we will see this. We will deploy this architecture live today. We have a data store here. So data store, I think I have explained it in my next slide. Yeah, this is the lab architecture, if you see it. So in this architecture, we will use Terraform to deploy this entire architecture where on Google Cloud Platform. And then here we are using the data store, which is nothing. It's like a RAG. You can think about RAG. And also you can think about it's a vector database. So it performs a lot of things. It will chunk your document into the pieces, and then it will convert into the vector or index, and it will also store it. Think about data store as a managed vector database, which will do everything for you. It could be a structure and unstructured knowledge basis, right? When I say structure means structured data where you have like data in the table format, right? When you say unstructured data, it means data could be anything like text, images, PDF, right? Then we have something called Vertex search, where user will send the prompt to get the response. Now, Vertex search is nothing. It's like your AI application, search-based application. Okay, and then we have some Python script which will load the data, and then we will query the our prompt. You'll see this in the lab. But before that, let me just explain you what exactly the data store. So in the rack, one important part is the data store. I'm talking about the Google side, and this is where your AI can look up the extra information beyond it was trained on. So data store can be website, structured data, unstructured data, could be your database or anything, right? Could be your PDF file or anything. So think about data stores like a library of your AI, right? As I talked about. Vertex AI is a kind of a Vertex AI application which you can find the information quickly, no matter where it is stored in BigQuery, storage, cloud storage, or any other Google Cloud services. You can find the relevant information. You can set it up for different needs like document search. I will talk about there are different search apps are available in the Google Cloud like document search, media search, healthcare, e-commerce product, or even we have the agent space. If you are aware of the agent space, like this is a very smart Google Google search capabilities, which you can use on your enterprise data and connect with the different source using the connectors, right? So all this AI search, right, use a RAG. It first search your data store, and then it creates an answer based on what it found, and then making the response accurate and relevant. So we are going to um, do this live demo, but this is the QR code that you can scan it. This is basically a repository where I have included a step-by-step deployment instructions, where you can follow along and do the demo on your systems, right? So you can simply find this repository, or just scan this QR code and follow the instruction. Right now, I'm not going to help you to get the live demo, to get the workshop, but I'll show you some the demo which is already there, because setting up things from the scratch is going to take a lot of time. I want to avoid this time. Okay, so let me just show you the live demo here. Um, So this is my Google Cloud Console, and in my Google Cloud Console, I have this project called RAG Demo. And in this project, if you search for AI application in the search bar, just click on the AI application, you will land into this page. Okay, so this is a services. It's called a discovery engine. Basically, you must be having a discovery engine admin role to access, and the discovery engine API has to be enabled. All this information you can find it in my repository over there. Everything is clearly step by step mentioned. Just follow along, and you should be able to deploy this infrastructure and test it by your own, right? So some of the infra I have already deployed it. Let me tell you here. There are two apps. Right now I'm in the app section. There are two apps: manual app and test engine. The manual app is something that I have created it using the console, and the test engine is something that I have created it using the that repository using the Terraform. Okay. Similarly, I have the data store. So this data store is something that this manual DS is something which was created using the manual way, and this one was creating using the Terraform way, right? One thing I forgot to explain you, I think this architecture I forgot to explain you here. So if you look at this architecture, I have this AI application and then this data store. The data store is something that where we feed our own data, right? So what I have done, I have recently completed a generative AI certification. So I have added this certification as PDF file to this data store from the Google Cloud Storage, and then from this bucket. And what happened behind the scenes, this store, all the content of this PDF file has been imported and indexed to my data store, and then I have attached this data store to my AI application, right? And if you look at this here, there are certain steps. So the first step, you can deploy it using the Terraform. Then the second step, you can load the data using the script, or you can load the data using a manual way, right? Third is you can send the prompt and test it, right? It's a very simple and straightforward architecture, right? Now, no much complications here. Now let me go back to the console here. Now first, let me test. Let me show you this data store manual, the manual one. If you look at this manual data store, you find the data store ID, and the type is unstructured data. You can select structured data as well. The serving state is enabled. The reason is global, and this is the app, manual app, which is attached to this data store. And this is the size of the data which has been indexed, and the number of document. The last document import is 7th of August, right? So I think a couple of days back I was testing it, and then this is the document, right? This is the document that you want to feed into this data store. right? You can do it by two ways. You can do it using the Terraform script, using the Python script. You can load the data using the script, or you can manually do it also by clicking the import data, right? So if you look at it here, I have this is my private bucket, enterprise private data bucket, and this is the file, right? This is the file. If I show you this file, let me show you this file. Okay, this will not show. Okay, let me just download it. Okay, so basically, what exactly is it? This is my generative AI certification, data, all these things, and this is something. I think this is my generative AI data file. Yeah, right now it's a private bucket, so you can think about it. That is the information, and you see that this information is already indexed. You see that this is already indexed, right? Which means all the content of this PDF file have been chunked, pieced, and stored as a vector, right? As a numerical representation, index format, right? So this is why we called it index, and the status is fine. Now, what we are going to do, let me test it. Unfortunately, if I try to use, let me just click here, manual app. Yeah, this one. You can search it from here also, from the console. You can just go to your app and go to preview. If you try to do something, let's say hi, something hello, I think I'm getting some problem because there is some issues with the Google Cloud Console. I have already given the feedback. I don't know, it's not working. But there is another way we can use the API and test it, right? So what I have done in my Cloud Shell, if you look at this repository, the repository which I have shared on the QR code, this is the same repository. I have cloned this repository on my Cloud Shell. Okay, now I want to test it. So I have, let me open this into the editor. So in Cloud Shell, you can get the Visual Studio Code like editor in your Cloud Shell only. So you don't need to copy this on your local Studio Code or something in any other IDE terminal. So right now you can see that I have all the your Terraform code, and there is a query called query2.py, wherein this is my project ID and this is the data store ID, right? This is the ID of my data store. Which ID? The data store ID and the location. Now the question is here, what I am going to send the prompt, what is the issue date, expiration date, what is my certification issue date, expiration date, ID of Google Cloud certified generative AI certification. So this is the prompt I am sending to my app, and behind the scene, what it does, the application will find this information into my data store, in which is in the index format, and give me the right response. Okay. Now let's test it. I'm going back to my terminal. If I do query see, you can see the answer, right? You are recognized as a Google Cloud certified generative AI leader. Your certification issue date is this, because I'm just recently got this certification, and this is the expiry date, and this is the certification ID. All this information is coming from where? It's coming from your private data. And coming how? Like, it's coming because of the RAG. Now, RAG is an inbuilt capability of your data store, which is this. Now, let me show you one more thing. If I could be able to show you here. Yeah. Where is that? Yeah, this one. Yeah. So this was my certification, right? This was my certification. You can see the issue date is July 30, the expiration date ID. This is the same data which I have imported into this data store. You can see this one, right? So this is how it's coming from. Now there is another app I want to show you, which was deployed using the Terraform. And in this data store, if I go to here, so yeah, so this is my this is the second app which is deployed using the Terraform, and this is the data store. And so now let me take a look at this data store. What are the document is indexed here? So you can see there are a lot amount of data, and this data is a public data of the Google Cloud information, like all the private information, like their revenues, their planning, all those Q3, Q4 revenues and all those things. So all these data are indexed. If you want to look at any of this file, you can see this. These are the document, right? And each document you have it around 9 or 10 pages. All this information are indexed into my this data store, right? If you want to ask any questions from your app, it will give you the right answer. So let me send one more prompt. I show you here. There is a query, this one. Here also the data store ID is now changed back to the the automated one, and this is the query I'm sending to my application. What is the Google Cloud versus AWS market share comparison? Now let me just run this. Now you can see that your application, Google search application, providing a very nice information about what you have asked, and this information has been is basically coming from your private data, right? The data which has been indexed, right? I hope this lab is useful for you. You can just try it out. Uh, for me, it's not working from the UI console, but if you want to try, it's pretty much very straightforward. You can create the app. It's very simple, right? You can go with the manual also. You can simply I'm just I'll just help you to how to create. Just select on the type. You can select which type of search you want to create. Agent space is not available for you, because it's available for the partners and for the customers. But you can go with the custom search, custom healthcare, media search, and all those things. You go with the custom search first. Simply just put the name, anything, demo app or something, the company name, something ABC, and then continue. And here you can create the data store or attach the already existing data store. It's simple, right? You can just create a data store. Now here, when you create the data store, it will ask you to create the to select the data store. This is where you will upload your private data. It could be a website, BigQuery, cloud storage, API, SQL, Spanner. You can see a multiple source. Even you can go for the Google Drive also, Gmail, and there are many external party source connectors are also. For this, you can select with the cloud storage. You can select what kind of data you are importing. You can go with the unstructured, structure, enhance, whatever you need. And then the synchronization frequency, like how frequently it go and fetch the information, right? Because every day you are putting lot of data. So you can go with the periodic, you can go with the streaming, right? Depending on your need. And here you can just find the bucket where your private data is stored. For example, I have enterprise data bucket, and then I'll select any file, or maybe I can select the entire folder, and then click continue. Right? Put the data store name here, DS something, right? And then click on create. Right? I'm not going to create it, but it's pretty much very straightforward. This is a manual way of doing it, but if you want to do it using the Terraform approach or using the automated way, this repository has everything. You can go with the option 1, Terraform and CLI base, and the option 2 is Google Cloud Console. pretty much very straightforward. What are the prerequisites are required? You can clone the repository, enable the APIs using this command, verify the APIs, authenticate, and then everything is pretty much same. But when it's come to loading the data, you have to run this, right? It will load the data using the Python, right? And then you can run this. All right, so I think let's go back to my slide. So any questions so far? So I think that's all for this session today. You can, this is again the QR code if you have forgot to scan during the initial slide. So this is again I'm sharing on my slide. You can scan the QR code and connect me if you want. Meanwhile, I'm ready to take your questions. Abhishek, over to you.
Thank you so much. Thank you for the lovely session. And apologies everyone for small glitches. Uh, okay, so we'll quickly take the questions. So Sumeji, if it's Abhishek's Sahi question, if my document is very big, how can Gemini Pro with RAG in Google Cloud break it into parts and still have accurate answer?
Yeah, even if your document is too large, it can break. It can. It has the capability to break down into the chunks or pieces and convert into the indexes. I have shown you, right? I have a around GBs of PDF files. Let's say you have a 10 GB of PDF file, and in this PDF file you have a multiple pages. Let's say 1,000 pages. So what it will do, it will convert into the chunks. Let's say 50 chunks, right? I mean 50 pages in one chunk. So it will do some chunks and convert it into the embedding and store as an index in your vector database. So it doesn't uh, matter if you are adding whatever the size of your file, it can convert it.
Okay. Following that, we have another question from Abhishek again. At in a large-scale RAG setup with Gemini Pro on Google Cloud, how can we dynamically rank and filter retrieved chunks to avoid context window overflow while still preserving critical information?
Okay, so if you want to preserve the critical information, there is a service called Model Armor. If you might have heard about it, or you can also use DLP, Data Loss Prevention Service. There are certain tools and service available in the Google Cloud, which even if you try to upload some sensitive information, and those information get mistakenly indexed into your database. So by default, what happens when user ask a prompt, those sensitive information can be presented, which we don't want, right? It's for some companies organizations it's going to be a compliance issue. So make sure you use those model armor tools and set your expectations. There are certain services available like SQL injections, threat injections, and all those sensitive data protection. You can use that and protect your data.
Okay, great. So if anyone who still has the questions, you can drop more questions. We are taking that. Okay, next one is from Mr. Arpan. What do you use RAG for in a real world application for yourself?
Okay, for rack base, like since we are working with the customer to create the agent space. If you have heard about agent space, we are using, see there are different way to deploy your RAG based application, not a single way. First is you can go with the agent space. Let's say again data store is the right way of using the RAG based approach, because agent space allow you to connect a different data source connector. It could be Outlook, Gmail, and all your data is going to be indexed in your data store. So that is the one way of managed service. Another way is a next gen AI application, which you can build it and customize it. For example, you can run your AI application onto your Cloud Run service and expose it to your load balancer. And behind the scene, what happened that the Gen AI application which is running on your Cloud Run, you will design in such a way that all the embeddings or all the vectors are going to be stored in an external vector database. For example, Pinecone. If you heard about Pinecone, it's a very famous vector database which you can use the API keys and store your embeddings or vectors into the vector database. Right? You can customize it. So there are many ways to do it in the production grade level application, depending on your need.
Uh, okay. So next is my personal question. So I
Mhm.
also have worked on couple of rack pipelines. So let's suppose like there are some pros and cons of using vector databases and other databases. Like, can you please like put some light on that domain? Like, if we are going with vector database or we want to go with graph or some other database.
Sorry, Abhishek, something has broken. Can you come again, please?
Okay. So since I've also worked on couple of rack pipelines
Mhm.
and wanted to understand like what are some of the pros and cons of using vector database, or we can go with other databases, let's say graph or other. What are some of the pros and cons of using different type of databases?
So see, vector database are designed to store specifically for the vector. You cannot store vector into a MySQL database, or let's say, or any other not traditional database, because they are not designed for that, right? When it comes to the vector database, there are many players in the market, like Pinecone have, Graph has, Neon. There are Manage is also right from cloud. So all are having their own capabilities, right? Maybe they are running, some of them, like the pros are basically, if you're using the cloud based, everything is managed for you. You don't need to manage the underlying patching or everything. You just use it and pay as you go model. But when you go for other one, like marketplace, or you want to manage onto your virtual machine, then you might have to manage on having a full control over those vector database. So I mean, I would say it's like a performance. It's like every database is providing with certain capabilities. Maybe one database is having some extra features. Someone might have a specific feature, might maybe someone doesn't have. So depending on your choice, right? And also the pricing is also the factor of choosing which vector database you want to choose, right? So this is also a factor, you know
Oh,
because because when you have a small team, you don't want to manage it, so you can go with the managed vector database. But if you have a team, you can go with the full control database, wherein you can save some amount of money, right? So this is how you can choose it wisely.
following this, like that was my follow-up question as well. Like, so there was one struggle I had in past, which was like automating like regular updates without manual effort of the like data. If I'm talking about how we
Mm-hmm.
can automate like automate the data updates over our knowledge database now.
Yeah, so you're talking about data ingestion streaming, like I showed you, right? You can set a periodic synchronization, right?
Okay.
Hourly, maybe 24 hours, or maybe one time, whatever, depending on your need, how frequently you are updating the data. There are two ways. If you're using the data store, then there is no way to customize it. But if you're using the customized way, like I said, if you're running on Cloud Run and using the Pinecone, you can use the embedding model. You can use the cloud scheduler to set the schedule, and every 5 minutes or 10 minutes, it'll go and fetch the data, sync up the data, and store it, the update your knowledge base. And that's where how it works. You can, whenever you send a prompt, you'll get the up to date information.
Okay. Okay. Thank you. And next, we have a question from Dave. He's asking that
Mhm.
is it true vector embedding is basically work like people answer, break into vectors, and then reply it back in vector form, and then give the output?
So understand the concept of RAG. When you send a prompt, let's say you are sending a prompt, what is my order status? The the prompt, what is my order status, is also going to be embedded, is also going to be converted into the embedding, right? Second, then it will find the retrieved vector information which is already retrieved, which is already indexed. So now your post prompt is also indexed, your retrieved information that is already retrieved, that will become the augmentations, retriever, the questions and the retriever. And in that way, I said, right, vectors are the numerical representations and all the relevant context are closest to each other. For example, king, queen, and all these related words are closest to each other, and that is why the RAG is able to find the relevant informations. And then when it sent when you send your augmentation query to the LLM, then only it generate the response, right? So understand, everything is happening within the vector things, right? The query is also converting into the embedding. The retrieval content is also in the embedding format, right?
Right. Hope the question you have is answered. Next,
Yep.
we again have a like follow-up question from Urban. I think, Postgres allows vectorization of data. I think it must be something related to earlier question. Is
Mhm.
it different from Pinecone?
Postgres.
Yeah. Postgres allows vectorization of data. Is it different from Pinecone?
Um, it's different from Pinecone. I think yes, because um Postgres is a managed NoSQL database. Um, it's a no, it's a relational database. Sorry, my bad. Postgres is a relational database, SQL based. Pinecone is a vector database for a similarity search, right? So obviously, when you store your embedding in a Pinecone, you will get a high dimension vector embedding. But when you do the same in the Postgres, you are basically storing those vectors in a structured data, and structured data sometimes very slow, right? Um, and these are not recommended to store the embeddings. Though you can do that, but it's not recommended. So Pinecone obviously different, and they provide a NoSQL kind of a database, and very high dimensional vector embedding is storing and querying the vector embedding. It is basically, the Pinecone is used for various ML models also, if you can see that, and it is very good for semantic search and recommendations. But Postgres is used for relational database like general purpose storage for transactional data, right? So you cannot compare with in terms of embedding.
Okay, okay, Smaj. Uh, that's all. If anyone has any more questions, feel free to shoot. We can take a couple of more, or as we are already heading towards the end of this session. Hope all of you have enjoyed this session and learned how we can deploy a RAG pipeline in production, right? And hope we see more projects coming up in the community soon.
Thank you so much, guys. Thank you for having me.
Thank you, Sumitji.
Enjoy your
Thank
Sunday.
you, everyone.
Take care.
We'll be sharing the the recording of the session and all the resources as well in the post form. Okay. Okay. Thank you, everyone. Thank you for joining. Have a
Thanks,
great day.
everyone. Bye bye.